All right, we're going to get into our last um, section here for our unit P, or our chapter P. So there's the bell work here. If you haven't tried it already, go ahead and pause the video and work through this bell work. If you've already done it, then we will work through it together here for the answer. Now, the first thing here we want to do with these is factor everything. Even the top, because you may be able to cancel something or reduce something right away. So here in the bottom, we're going to factor out just an x. So you have x plus 4. Mark that out. And then this would be a 6. X plus 2. Nothing cancels or anything there. So we're actually going to leave it as x plus 2 moving forward. Then we're going to take this whole thing and multiply by our common denominator. Now, this is a good time here to note that x cannot be 0 or -4. You get -4 from this part right here, and you get 0 from this part right here, 0 from this part, -4 from that part. Once you do that, or we're going to multiply by our common denominator, which is x plus 4. And we're going to distribute that into all three of these terms. So here our x plus 4 is going to cancel out. So we get 3x equals. Here just the x's will cancel out. So I get x plus 4. And here my x and x plus 4, so everything cancels out. And I get 6x plus 12. Well, here I'm going to combine like terms and get x on one side. So this is 1x plus 6, that's 7. So I'm going to subtract 7x. Cancel and cancel. So I get minus 4x equals 16. X equals -4. But if we remember over here, we said x could not equal -4. So in this case, I have no solution. Okay. Please remember to restrict your domain or tell me what x cannot be. Or if you don't do that, you need to make sure you plug it in and check your answers. Well, so chapter 9 is about modeling with equations, and that's just a fancy way of putting you're going to solve word problems using equations. So there are a few formulas here to remember. One of them is that your interest equals your principal times your rate. Okay, for interest, like on a money account or something like that. Another formula is distance equals rate times time. And you could rearrange that for any letter there that you want to know that you want. And we'll hit several different types of problems through this. And this will be a 2-day lesson. So there are 10 total slides here. So, and I think I have like 8 examples or 8 different problems. So if you want to watch some of them and then go do your day 1 homework, you can do that. And then day 2, you can watch the second part and then do your day 2 homework, or you can watch this whole thing one day and just work on the homework on each day. I'm going to leave that up to you. A rental car company charges $30 a day and 15 cents a mile for renting a car. Helen rents a car for 2 days and her bill comes to $108. How many miles did she drive the car? Okay, well, we're going to set up an equation. So the rental company charges $30 a day. Well, she rented the car for 2 days, so that's $60 plus 15 cents a mile. So that's 0.15x equals 108. Okay, don't forget this little fact here. She rents the car for 2 days. This is $30 a day. Okay, so this is just a linear equation. We're first going to subtract the 60 over. So you get 0.15x equals 108 minus 60. We get 48. And then divide by 0.15. And you get 320 miles. Okay. So this one involves a linear equation, which when you have linear equations, it's very easy. This is pre-algebra type problem here. And our problems will go from linear all the way up to rational. So Mary inherits $100,000 and invests in 2 certificates of deposit. One certificate pays 6%, and the other pays 4.5% simple interest annually. If Mary's total interest is $5,025 per year, how much money is she invested? Did she invest at each rate? Okay, so we kind of have 2 things going on here. So Mary has a total of $100,000 to invest in 2 different things. One of them is 6% and one of them is 4.5%. So you're going to take some money at 6% plus some money at 4.5%. And in the end of 1 year, you get $5,025. Okay. Well, we're going to fill in this side of the problem. So I have 0.06 times some number amount, however many dollars we're putting in there, plus 0.045 times. Now she has a total of 100,000. She already spent X. So over here, it's 100,000 minus X, minus whatever she spent over there, equals 5,025. Okay. So now all we have to do is solve this. So we have 0.06x. We can distribute this. 0.045 times 100,000 is 4,500 minus 0.045x equals 5025. Subtract 4,500 and combine like terms. So 0.06 minus 0.045. So that part canceled. Here you get 0.015 x equals 5025 minus 4,500 is 525. And then you're going to divide by 0.015. Both sides by 0.015. So x in this case is $35,000. Well, the question asks how much money is invested at each rate. So x represented 6%. So it's 35,000 at 6%. Well, to figure out at 4.5%, we're going to take 100,000 minus the 35,000. And you get 65,000. And that subtraction's right here in the problem. The 100,000 minus x gives you the 4.5%. Make sure that you answer the question that's posed in the problem. Okay, a square garden has a walkway 3 feet around its outer edge, as shown in figure 1. I don't have figure 1, but this is what figure 1 had. It had a garden. And around that garden was a 3-foot walkway. So the picture looks up something like this. If the area of the entire garden, including the walkway, is 18,000 feet square, what are the dimensions of the planted area? So it's wanting to know how long is, it's a square, so this is x and this is x. So how long is that, or how big is that? Well, this side right here is x plus 3 on each side. So this is x plus 6. And this side here is the exact same. It said it was a square. So that's x plus 6. So if I take those, x plus 6 squared, multiply them by itself, because that's how you get area, that equals 18,000. To solve for x, we're just going to take the square root here. See, x plus 6 equals. Now, normally when we would solve, we'd take the square root and we'd have plus minus. But here I don't want plus minus because we're actually talking about measurements and lengths, and I can't have a negative length. So this is actually a decimal right now. So we're just going to kind of keep it for just a second. And then we're going to subtract 6. So x equals negative 6 plus radical 18,000. And we can put all that into the calculator at once. So negative 6 plus the square root 18,000. Then you get about 128. So the dimensions are 128 feet by 128 feet. Okay, a man who is 6 foot tall wishes to find the height of a certain 4-story building. He measures its shadow and finds it's 28 feet long, while his shadow is 3.5 feet long. How tall is the building? Okay, so we got this guy. He's 6 foot tall, and his shadow, let's say it goes this way, is 3.5 feet. Now, when solving these problems, you have to really look at labels. And we have this building over here that we're going to say is X tall. We don't know how tall it is. That's what we're looking for. And its shadow is 28 feet tall. Now we're going to use proportions to help us solve this one. And it doesn't really matter how you set up your proportion as long as you're consistent about it. So my proportion could be 6 over 3.5 equals x over 28. It could be 6 over x equals 3.5 over 28. It could be 28 over x equals 3.5 over 6. You just have to be consistent about how you're setting it up. So I'm going to say 6 over 3.5 equals x over 28. Okay. So there's a lot of ways you could do this. A lot of people cross multiply. I tend not to do that, especially if x or something crazy is there on the bottom. I like to multiply by my common denominator, which is 3.5 times 28 in this case. Your 3.5 cancels, so you get 6 times 28. And then your 28 cancels, so you get 3.5x. Then here we're going to divide by 3.5. Whoop. So x equals 6 times 28 over 3.5, which is 48 feet. So that building there is 48 feet tall. I don't know, that should be enough to get you started on the day one stuff. So if you want to pause this and kind of go look at that day one stuff, you can always come back and continue this video if you feel like you need to see some additional examples. But there's the next three here should be on day two. So a manufacturer of soft drinks advertises their orange soda as naturally flavored, although it contains only 5% orange juice. A new federal regulation stipulates that to be called natural, a drink must contain at least 10% fruit juice. How much pure orange juice must this manufacturer add to 900 gallons of orange soda to confirm the new regulation? Okay, so in the end, we need 10%. I currently have 5%. And I'm going to add, where's it at? Pure orange juice, which is 100%. Okay, so this is what's happening. Now I'm going to put, these are my percentages. Now I'm going to kind of put the weights on them, which here I have that the weight is in gallons. So it's asking me how much pure orange juice. So that means this is going to be my X amount. Okay. 900 gallons of orange soda. That was the 5%. And in the end, I just add those two things together. So this will be X plus 900. So I need to combine these two things. So we have 0.05 times 900 plus 1 times X. 100% is 1. 0.1 times X plus 900. Okay, and we distribute, combine like terms, and now we're just solving for X. So 0.05 times 900 is 45 equals X equals that's a plus X. 0.1X plus 90. Okay, so we're going to subtract 0.1X. That's 0.9X. And we're going to subtract 45. 45 and divide by 0.9. So 45 divided by 0.9 equals 50. So they have to add 50 gallons of pure orange juice to this 900 gallons to get 10%. And they're going to end up with 950 gallons of juice, but it now has 10% fruit juice, which is what the federal regulation wanted. Okay, because of an anticipated heavy rainstorm, the water level in a reservoir must be lowered by 1 foot. Opening spillway A lowers the level by this amount in 4 hours, whereas opening the smaller spillway B does this job in 6 hours. How long will it take to lower the water level by 1 foot if both are open? So this, I call these kind of work problems, even though it's not people working, it's still something working. And we have to figure these out by rates. So we have spillway A and we have spillway B, and then we have them working together. And in order to compare these, we have to look at their unit rates. So spillway A does this job in 4 hours. Spillway B does it in 6 hours. And we don't know how long it takes for them to do it together. But I know that the unit rate for spillway A is 1/4, meaning it can do 1/4 of the job in 1 hour. B can do 1/6 of the job in 1 hour, and together they can do 1/x of the job in an hour. So I'm going to take this column here, to set up my equation. So I'm going to say 1/4 plus 1/6 equals 1 over x. We're still solving for x to get our time together, but you can't just like add these and divide by how much is there. It's not that easy. You have to look at the unit rate. Okay, so easiest way here is to get rid of these fractions. So we're going to multiply by 12x. That's my common denominator here. If you want to write it, you could do 4 times 6 times x if you want. That's another one that's easy to just multiply by everything that's there. But I know that 4 and 6 go into 12, and then I need the x there. So 1/4 of 12, or 12 divided by 4 is 3. So here you have 3x. 12 divided by 6 is 2. So you have 2x. Here your x's cancel, so you get 12. And you have 5x equals 12. Divide by 5. X equals 12 over 5. And 12 over 5 would be 2 hours. And that'd leave you 2/5. And 2/5 of an hour, let's see. So 2/5 times 60 is 24 minutes. Okay, this was 2/5. So here's where your 2 hours comes from. And then your 2/5, you're going to take that times 60 and get your 24 minutes. So for them to work together, it's going to take almost 2.5 hours to drop the reservoir by a foot. Oh, last one here. Bill left his house at 2 p.m. and rode his bicycle down Main Street at a speed of 12 miles per hour. When his friend Mary arrived at the house at 2:10 p.m., Bill's mother told her the direction in which Bill had gone, and Mary cycled after him at a speed of 16 miles per hour. At what time did Mary catch up with Bill? Okay, so let's just kind of sketch a picture here. So here's Bill. He starts at 2 p.m. and he's going so far. Okay, we don't know how far he goes. It doesn't matter, but he goes 12 miles per hour. Okay, Mary shows up at 2:10 p.m. So just 10 minutes later, and she pretty much chases after him going 16 miles per hour. And it says, what time did they catch up? Or what time did he catch up? She catch up. So we know that they caught up. Like, we know Mary caught up to him. So we know that the distances are the same. So the distance of Bill is the same as the distance of Mary. And at the beginning, we said that distance equals rate times time. Okay, I have the rates of each, but now I need the time. Now, if we look here, we can figure out who traveled longer. Okay, Bill started at 2 p.m. Mary started at 2:10. She started after him, which means Bill's going to end up riding longer. So if Mary travels for X hours, Bill's going to travel for X plus 10 more minutes, because there's a 10-minute difference. Well, 10 minutes is 1/6 of an hour. Okay, it's 10 over 60, which reduces to 1/6. So then we're going to plug those into the equation over here. So distance equals rate times time. So Bill's rate is 12 times his time was X plus a sixth. Mary's rate was 16. Her time was X. We can distribute, we can combine like terms and solve for X. So I'll distribute this 12. So 12x, 12 divided by 6 is 2. 16x. If I subtract 12x, I get 2 equals 4x. Divide by 4, x equals a half. And remember, x was in hours, so a half hour, so 30 minutes. So they catch up in 30 minutes, which is 2:40 p.m. And I know that because x here is 30 minutes, and she started at 2:10. Here, I have to take my 30 plus the 10 minutes equals 40 minutes, and 2 p.m. plus 40 minutes is 2:40. Okay, so it said at what time, which is why we say 2:40 p.m. Okay, you have your 2 different assignments on WebAssign for you to go and finish. Make sure that you have taken screenshots and put those onto Schoology for me to look at and grade. If you have any questions, feel free to reach out.